Hello everybody. I guess I'm online right now. So thank you very much for joining this stream. This will be my first really, I would say real stream, because I did a test stream a couple of days back. I was talking about Blazor, but this is, well, the first stream in the series that I want to keep going for the next few months, I guess. And during this stream, I would like to create basically with you or together with you a social media network from scratch using domain-driven design principles and patterns. Please let me know via the chat if you can hear me okay. I tweaked my sound a little bit from the test stream, so I hope that right now you're able to hear me better than before. First of all, I have to say that this first stream won't be or we won't write too much code, because first off, I would like to clarify just a little bit what domain-driven design basically is. So we'll mostly go through the domain-driven design basics during this stream, and we'll set up our initial solution in Visual Studio. And starting from the second stream, basically we'll start writing code, and we will basically start to write our application from scratch. As you will see, today we'll basically create the new solution. So we'll start from new solution, and that's it. The reason why I wanted to do this stream or this type of experience, like writing code or creating an application basically together with you, is that as I was discussing with a lot of developers and as I was working as a software developer, I noticed that most of the times when you are working for a company, you're basically just assigned to a project and you have to write code there. But in 90% of the cases, you are never assigned to a project that starts from scratch. And this becomes a problem because you can become very good at what you do, at adding new features or fixing bugs, whatever. But the problem is then at a certain point when you will be faced with the task or challenge to create a new project from scratch or a new application from scratch, we usually don't know how to start it. And this is a very good way to get a little bit accustomed with what starting a new project actually means, because we will have to talk about a lot of different things like the architecture, the software design principles that we want to apply. In our case, it will be domain-driven design. But then you will see that even if the theory of domain-driven design is very cool and it seems, well, complicated but really achievable, we'll see that there are a lot of challenges that come during the way. And the first major challenge that I have encountered on such project was basically that, you start to write your domain, everything is okay, but then at a certain point you have to implement also the infrastructure or the data access layer. And this is the moment when everything becomes a little bit more problematic, because the ORMs that you'll probably use are not designed to fully support domain-driven design principles. And you will find yourself in scenarios that you will have to change a lot of things in your application. And you will see that maybe domain-driven design principles cannot always be taken ad literam, I would say. But there are a lot of other challenges that we will face during development. One of them, or another challenge, would be that we'll write a lot of code, really a lot of code, before starting to do anything that has to do with UI. And the way we will check if our code works as expected is, of course, through unit tests. So unit tests are also a very, very important part of this approach. And overall, I thought that streaming this kind of experience might benefit a lot of fellow developers that have never worked maybe with these domain-driven design principles and patterns. And it would also help me to better understand these challenges and all the concepts of domain-driven design. So this is kind of like the background that, or the background why I have created, or why I thought to create this stream, and to start to at least try to stream as consistently as possible. And speaking of consistency, I just want to say that my plan is to run this stream each Wednesday from 7 p.m. So it's exactly the same hour like now. It's 7 p.m. Eastern European time. So well, you have, if you're watching from another time zone, you would have to slightly adjust your time. But other than this, I think that we'll have plenty of work to do for the next, I would say, month. And surely there are people that maybe start streaming, especially now in this social context where we can't do too much outside. But my plan is to definitely continue doing this project also after, I would say, life would resume in a more normal way. So we'll start today right away with this domain-driven design basics. We'll go through the theory behind, and we'll at the end we'll basically we'll switch to Visual Studio and try to figure out the initial setup that we would need. And what I think when I say setup is about the folder structure that we want to have, or how do we organize our projects inside a Visual Studio solution following this idea of domain-driven design basics. Okay, before I start, I would just kindly ask you to write something in the chat. Only that I just want to make sure that you can write in the chat and that I can read what you write, because one of my expectations is that you would ask a lot of questions, and this is very, very important. After this stream, I would really like that these concepts that we talk about are really clear for you. And doing this in a very non-formal way, like a stream, I think it's a great opportunity for you to ask the questions that you want to ask. Or if you want to, I don't know, say something that kind of complements what I say, then you're, well, welcome to do that. And later in the other episodes, when we start writing code, I will probably face also some challenges at certain points, or bugs, or things that don't compile and having errors and so on. You can just feel free to write in the chat whenever you see something that might not be okay. So please use the chat. It's very, very important for me to get your feedback, because this is the way I am able to know if you understand what I'm talking about, or if I'm clear enough, and so on. So please use the chat. Okay, let's start now with the domain-driven design basics. When it comes to domain-driven design, this is a concept that is here for some time, I would guess. And there are some books written on it, and the very first book that came out, and that was called Domain-Driven Design by Eric Evans. It was in 2003, and the subtitle of this book was Tackling Complexity in the Heart of Software. And this title already reflects a lot of what actually domain-driven design is. It's basically a bunch of patterns or principles that we can apply if we have to develop applications that are fairly complex. So domain-driven design is not something that we would implement for a very basic API. It wouldn't make sense, as we will see the overall overhead that domain-driven design would add to this would really outweigh the gains that we would have from such an approach. And in this book, Eric Evans sketched a first theory of this principle of domain-driven design. So this is really the first time that this concept was used, and Eric Evans was the one to coin this term domain-driven design, which is also called DDD. And I would very often refer to DDD because it's much shorter. But then in all the other years, a lot of other great books followed. Another very good author when it comes to domain-driven design is Von Vernon, which wrote, I think, a bunch of different books on how to implement domain-driven design. And in this screen, you see the one of Von Vernon's book on the right part. And then there is also this book from Jimmy Nielsen, which is called Applying Domain-Driven Design Patterns. And this book is very interesting because it's applied to the .NET ecosystem. And that's why, as a .NET developer, when it comes to domain-driven design, I would say that this book, together with, of course, Eric Evans' book, are really the first go-to resources to study about how to architect the application that we want to start together. And of course, right now, if you do a search on Google or Amazon or whatever other service, you will notice that there are a lot of books written on this topic. And most of them are very interesting, since they are not, or a lot of them are not only theoretical books, but also books that reflect some experience from practical work, which is very, very important and valuable for all developers, I would guess. Now, the goal here is that we want to understand the value of domain-driven design practices, and to understand how we can employ them basically in our applications to make our application a success. And we'll see that the biggest problem with applications arise when they become more and more complex. Now, of course, there are some cases when we start working on a new application where we don't know exactly how complex that application will get. But I would say that in most scenarios, we will have a brief idea about the complexity that could evolve from the initial project. And understanding the complexity of the project is very, very important, because this is actually the step or the point where you can decide if you want to use domain-driven design or not for that specific project. Now, why should we care about domain-driven design? Well, first of all, because under this term, which is kind of like an umbrella, basically we find a lot of principles and patterns that help us to solve difficult problems. And as you write software, I'm sure that, well, you encountered a lot of different challenges, and you search for ways to overcome them. Now, a lot of those challenges are very common for complex projects. Even if we might think that one of our projects, or the project that we are working on, is like very specific maybe, and that the problems that we face might not be faced by other developers working on different other projects, when it comes to complex software, the challenges mostly arise from the system itself. So how is this system designed to work together? Because actually what we have in the end are a bunch of puzzle pieces that we have to put some way together in order to have an end result, which is the application that we need or that our customers need. So in domain-driven design, you will find a lot of principles and patterns that are very, very useful in different scenarios. And why I want to emphasize this point is that even after I have started to work on a domain-driven design project, and after I have started to study domain-driven design and understand how it is supposed to work and the core principles of it, I found out that also when I switched to other projects that for which we did not use domain-driven design, there were still some principles from domain-driven design that I started to employ in my regular projects, let's say. Because those principles you'll come to acknowledge that they are really very important, and they really can help you out in the challenges that you have. Then a next very important point is that starting 2003 until now, we have like 17 years in which domain-driven design was employed for a lot of very complex systems. And it has a history of success with it. That's why if we are challenged to create a new application, a new system that has a certain amount of complexity, going for domain-driven design is like a warranty that our project or that the application would be, I would say, fairly successful. Then also another very important part of domain-driven design, conceptual part, is that it aligns with practices from our own experience. And this is something that we'll talk a lot about today. Also when we'll talk about the language that we are using, and that plays also a very big role in domain-driven design. And the fact that it employs basically patterns and principles to which we can relate from a personal experience usually helps us to better understand how to overcome certain problems or what to do in certain scenarios. Then another very important part of domain-driven design, that if applied correctly, it would lead to a very clear and testable code. And as I mentioned earlier when I was doing the intro to this stream, I was saying that, we won't write any UI for a very long time from now, and that the only thing that we will write to check or to see if our code works are unit tests. And this is why in the end we'll find ourselves in a project that is really heavily unit tested, and we can have a kind of warranty that the code that we wrote performs what is supposed to perform. Now, from a testing perspective, a lot of times when people apply or when teams apply domain-driven design, they also go for a test-driven design. So it means that they try to write out unit tests first that kind of reflect behavior of the domain that we are trying to model, and then they are implementing it. As for our project right now, I won't go for the test-driven design. Not because I think it's not okay, but I'm more familiar to first write the code and then write the unit tests to see if my code compiles correctly or if it gives the correct results. But here there is one important thing that I would like to emphasize, and it is the fact that when you are writing unit tests, don't try to cheat. And I know also from my experience that when you are writing unit tests, you just try to write them in a way that they pass. When you go for domain-driven design, or generally, it's not okay to do this. So try to be really sincere to yourself, and try really when you design your unit test to think about all possible scenarios that could arise and that could break your code. Having a test that really cover a wide variety of scenarios is very, very important when we go for this approach. So let's go one step further right now. So right now I would like to basically address the way we are normally accustomed to work on projects, even if we work by ourselves on side projects or in the teams that we are working on at our companies and so on. And the first thing that we usually do is write code. Basically, what we get is probably a story somewhere or an issue in GitHub, whatever, that tells us, okay, we need to do that. So we as developers, we try to understand that story or what is required from us. Then we start to write our code. And after we write our code, basically, the process of building software comes as a second place. So we first write our code, but then we think about the code that we have written, I would say in the context of the entire application. So this is where we start to think about how our code fits basically into the project, into the software that we are trying to build. And afterwards, usually it comes to understand the client's problems. Because most of the times we first write code, we build our software, and then we try to understand, okay, is this what really the customer needs? Is this something that solves our customer's problem or the problem that our software tries to solve? And then, of course, there is the part of solving problems which comes at last, I would say. However, this is, from my understanding and my experience, the way we are usually working in teams in most of the companies and on most of the projects. Of course, this is a very subjective experience. It could also be wrong, but I think that there might be some aspects that you all can relate to. However, and here comes the very, very big importance of domain-driven design. Domain-driven design is basically doing all these steps the other way around. So first we have some problems that we have to solve. First we define the problems. Then we try to understand the needs. What are the needs that our application try to satisfy? Then we think about, okay, how we build a software that would satisfy those needs that in turn would solve the problems. And last, or as a last step, we start writing code. This is why when you work on domain-driven design projects, there is usually a lot of planning that it is done before you even start to write code. There are a lot of meetings, there are a lot of different discussions with different stakeholders, and we'll understand today also why there is this approach. And only after we have understood the exact problems that our software tries to solve, and then if we can think about our software, let's say, as a system, only then, or only at that point, we can start to write our code. So domain-driven design is also a lot about planning and about understanding the software that we want to write and the needs that it needs to fulfill and the problems that in the end it tries to solve. So this is, from my perspective, once again, a very big shift in the way that we are accustomed to work as developers. Because normally we start by writing code, but in domain-driven design, we start always the other way around, from the problems that we have to solve to understanding the needs, to understand the system that we want to build, and then write the code accordingly. Okay, so what's DDD all about? Well, of course, it's about tackling complexity, as I already told. And as it is also the subtitle of Eric Evans' book, it's tackling complexity in the heart of software, which is the very important part. And here, once again, I want to emphasize a very, very important part, and this is that domain-driven design is not for each project. It's only for projects that, are there to build, or for which we need to build more complex applications from the business logic perspective, and we'll try to understand what exactly that means just in a few minutes. But then domain-driven design is also about interacting a lot with the domain experts. And if you remember the slide that I had previously, it was that we start by solving the problems and understand the needs. These are basically steps that are not fully dependent on us as developers, but are usually dependent on some business stakeholders. And the cool part about the principle of domain-driven design is that those stakeholders, those domain experts, even if they are not programmers, even if they don't have a very huge technical experience, they are part of the development team, because it's their input, it's their domain knowledge that would help us understand exactly those problems and how we can model our domain in a way that we could really solve those problems. And since in domain-driven design we basically integrate in the same team technical people and non-technical people, one very important part is that we have to speak a common language. And we'll come to this just in a few slides, because domain-driven design has a very huge point of emphasis on what is called ubiquitous language. So a language that both we as developers and the domain experts understand exactly the same way, even if the technical background is totally different. Then if we interact with these domain experts and we understand the problems that we try to solve, the complexities that we have, or the complexity in behavior that our software needs to reflect, of course we can then start to model our subdomains at a time. And we'll look just in a few slides a little bit deeper into what this exactly means. Now, a very important part about domain-driven design is also that we need, or that it focuses a lot on the domain logic instead of details, like for instance, how to persist data. And from my experience, or the experience that I had, was that this was also a very huge shift in the way I was accustomed to write code and think about the code that I write. Because usually when I wrote my domain classes, I always thought about, okay, but how will we persist these classes in the database, mostly using Entity Framework. Now, in domain-driven design, what we need to care about, at least at the beginning, when we model the domain, or when we model the behavior of the application, we just need to focus on that specific domain and on the problems that we try to solve. Of course, later, when we go to the data access layer part, we will have to think about, okay, how we can now persist the domain models that we have right now. And we'll see that no matter what ORM you choose to work with, the challenges that you will have at this step when you try to persist the models are not easy to tackle. But fortunately, there are a lot of good workarounds and good practices to try to keep the domain model intact and to shift everything that we need to make or to persist those models in the dull layer. For instance, if we need persistence models, then we could create separate persistence models in the data access layer, and we could use something like AutoMapper or a similar tool that we work ourselves to convert basically the domain models into our persistence models. But we'll talk a lot about this when it will come to persist the domain model that we will write till then. I won't dive too deep into this slide with the benefits of domain-driven design. Of course, it's very flexible because it focuses on behavior. It's also basically an approach that focuses a lot on the problem and how to solve that specific problem. It creates a guidance, I would say, for or shows us a path that we could take to solve those complex problems. In the end, we'll have a very well organized and easily testable code. Business logic, or the entire business logic, will reside in only one place, and this would be the domain layer. And we'll see that during the development we'll have a lot of challenges, or I would say a lot of urges or drives to put some of the business logic even outside of the domain model. But we'll talk about that just when the time will be right. And there are a lot of great patterns that we can use and apply to our applications, even if, once again, we don't write an application 100% following domain-driven design. There are some principles and patterns that we could use throughout all the software that we are writing, no matter if we use this approach, domain-driven design, or not. Okay, there are some drawbacks of domain-driven design, and usually when you read something on blogs and when you watch conference talks and so on, everybody talks about how great domain-driven design is, until you finally start to work on a project that implements domain-driven design, and then you realize that, it could be that it helps us a lot with tackling complexity in the software, but it also adds a lot of complexity, maybe not on a technical level or not on a code level, but on a how the team works level, I would say. And here the first drawback is that working on such projects needs a huge investment of time and effort, because as said, in these domain-driven design principles, or in this journey, there is a lot of planning, there are a lot of meetings, and the team is not just the developers, but it's consisted, or also non-technical people like domain experts are part of the team. And this is why you will see that when you discuss problems that you need to solve, we as developers, we tend to have, let's say, our language that we of course understand, but non-technical people won't understand us at all. Or not very easily. And this is the point where there could be a lot of miscommunication. That's why we need an ubiquitous language. We'll talk about this concept just in a few minutes. But I just wanted to emphasize right now that all these discussions, all this planning, all this basically describing the problems, takes a lot of time. And of course, it needs then also, we also need the time to write the code, to build it, to test it, and so on. So also from a financial perspective, of course, this would mean that the entire cost of that project will be higher than if we don't use these domain-driven design principles. Then there is a learning curve to it. And of course, when I started to first work on a project that kind of followed those domain-driven design principles, you have to study. You have to just go out and read, try to understand what those principles are, what those patterns are, what problems are they trying to solve. And I would say you need to, in a certain way, identify with those patterns and principles to really understand them. And this also implies that there is a higher learning curve. This in turn will also increase the cost of the project and so on. So if you want to deliver very fast, then probably domain-driven design is really not the best approach to use towards architecting an application. Then, of course, domain-driven design, it only makes sense when there is complexity in the problem. When we have just simple CRUD applications or very simple MVC applications that just need to present some data that doesn't even maybe change very often, going for domain-driven design is then surely not the wisest thing to do. Okay, now we can take a social network as an example, and here, by doing this, I'll also want to just a little bit discuss why I chose to create a social network for this stream. So if you have any questions, I'm not sure if you ask something, because I'm not able to see right now in the chat. Before we proceed, let me just check that. So let me check the channel itself. But no, I can't see any questions here. Okay, but I can see that we are well, 8 viewers. Thank you very much. 10 right now. Oh, that's great. Thank you very much for viewing. So coming back to this idea of social network, why I thought that it would be a good way to let's say to get into this domain-driven design. First of all, because it is an example of something with which we are all very familiar with. As said, when you work on a domain-driven design project, usually a very important part of those projects are the domain experts. And in this case, since social networks are very popular or very common, and you're watching this right now on a social network, we all can act like the expert or the domain expert for this type of application. So this was the first reason that that made me choose this as an application type to build using domain-driven design. But then another thing is that social networks, the way we know them, are fairly complex, because you have a lot of different parts in social applications. If we take Facebook as an example, we can see there a lot of different, I would say, domains maybe. First of all, we have, I would say, the core social network experience. So where you create a user, you add a friend, you can interact with your friend, you can remove a friend, and so on. So all these type of interactions, we can group together as being one module of a social network. Of course, you can also post things there, and in this case, you can interact with posts that other users have written, and so on. But everything, so if you think about all these things, they are about how we interact with different persons on the same social network. So this is why it's all this type of behavior is basically, or in my opinion, it belongs to the same thing, like the social experience. But then if you start to work further up in Facebook, you also see that, well, you have Facebook pages. And then you can create a page, that you can manage a page, you can update a page. So this is a totally different thing. Like we have a page management setup, or we could call this like a page management module in Facebook. On the other hand, if you want, for instance, I don't know, to run some ads, then you will see that you have also in Facebook like an ads management dashboard. So ads management, or ads generally, is another big module or another big part of such a social application. And just by having these simple examples, we already identified, I would say, 3 different subdomains, which would be the social, the ads, and the pages. All these parts of this application can be, of course, developed individually and are self-sufficient, independent parts. or in domain-driven design should be treated as self-sufficient, totally independent parts of that specific application. So once again, this whole idea, the entire idea of having a social network already gives us the most basic examples of different modules that need to work together. And this, of course, brings in the complexity, because we have first all the interactions between users, we have then all the behavior that are or that is related to Facebook pages, then we have all the behavior that is related to ads, and everything, if we think about the entire application as a whole, adds a lot of complexity. If we would go for a monolithic application, then basically we would have a very huge application that where every part is interconnected to every part, and so on. So this wouldn't help very much. This is why having a social network is a very good example on how to start building an application using domain-driven design, because we have also the experience, the personal experience on how a social network actually should behave, or what it should be possible in a social network. So now that we talked about the basic principles, more like the conceptual principles on domain-driven design, let's jump into what bounded contexts are. And with this, we start, I would say, very technical part, where the whole domain-driven design things becomes very, very technical. It's about how we model the domain, how we model behavior, how we model classes, how we interact with classes, and so on. So from now on, everything will be fairly technical. And the very first important stone or pillar in domain-driven design is what we know as bounded contexts. And the bounded contexts, as are defined by Eric Evans in his book, they explicitly define the context within which a model applies. And this is a very, very important thing. If we think back at this example of the social media network, we said that we have a social module for the social interaction, we have a pages module for the pages, and we have an ads module for the ads. Now, each of these modules could be perceived or treated as a bounded context in our application. So if we start to model our application right now, based on what we have said so far, we have these three bounded contexts, like the social, then we have the pages, and then we have the ads. Then talking about these bounded contexts is very, very important, because once again, each bounded context should be 100% independent and self-sufficient from all the other bounded contexts that are there. So the bounded context shouldn't be distracted at all by everything that lies outside the bounds of that specific context. And when talking about a bounded context, I also like to give a short example. And it's an example that reflects in a certain way also the way that we apply language, or in the way that we use language generally. For instance, the word meter. The word meter for us, or for me, for instance, it could mean simply a unit of measurement of distance, which is okay. But if you ask an electrician what a meter is, or what he understands when you say a meter, maybe he thinks about like the apparel that he is using also to measure electricity in a certain circuit. So you see that here this word already has two different meanings for two different contexts. For me, it has one meaning, but for an electrician, it could have a totally different meaning. And as I said, in domain-driven design, we have, or this difference in meaning should be also applied, or should be also visible in the software that we write. This means that, for instance, if I create an application that in some way has two bounded contexts, one for me and one for the electrician, in me as a bounded context, I would create a class that is called meter that would probably have, I don't know, like properties like centimeters, because well, we can transform a meter in centimeters, and a lot of other properties that we could think of about what a meter is. But then if I go over to the other bounded context, then I would create a meter. Then I would probably specify, I don't know, a more specific name to it, what it measures. Maybe it has also some physical attributes like length, width, and so on. So we name the class basically the same way, but since the same name, or basically the same name is implied in two different bounded contexts, in each context it means a different thing. And I want to go further with another example from this social network, the idea of a user. Now, when you sign up for Facebook, let's assume that you are in that social bounded context. And then you have a user which has a first name, last name, location, interests, whatever, all the other information that Facebook needs. But then if you go over to ads, then you still have a user, but that user has or needs also to have a billing address, a payment method, and so on. And the way we normally do things in I would say applications that are not following domain-driven design, we would probably create a user base class that has some properties, and then we would create, I don't know, ads user subclass, or an ads user class that inherits from user, and we would expand that class, of course, with all the properties that we would need for the specific class. So we would use inheritance. Now, in domain-driven design, this is a no-go. So we never do that, because when we are in the social context, a user strictly means first name, last name, location, town, whatever, so on, these type of details. Everything else regarding billing, it is outside of that bounded context. So this means that at a practical level, what we will do is create a class called user in the social bounded context with the properties and behavior that we need. And we would create then a separate class that is also called user, but in the billing or ads bounded context. And there, in that case, we will also attach to that user properties like billing info, payment information, and so on. And in this case, when we'll work, or even during we work on this project, we'll hear a lot of times phrases like this. In the context of social, a user means these things. In the context of billing, a user means these other things, which translates to properties and methods, behavior in our classes. But this is a very, very important aspect to know, that when we develop and when we work inside a bounded context, we shouldn't be distracted at all by anything that is outside of that specific context. Okay, then separating a bounded context, this is well, a very important part, and here of course there is not really a very, very clear rule and guidance. Okay, what are my bounded contexts? Usually what the bounded contexts are is something that evolves from the discussion with the domain experts, but the whole idea is that we have to separate the bounded contexts between them, and we have to separate the bounded context from all the other layers. So from the data layer, from the application layer, whatever. Then we can introduce separation, and we will see this how we'll do this in Visual Studio at the solution level, using, for instance, solution folders. But also by making sure that, for instance, when we are working in the domain layer, that we are never depending on class libraries or projects that we have wrote and that belong to a different layer. So this is a very, very, very important part. One thing that we will notice is that there is almost never the case where we can 100% apply all the domain-driven design principles and patterns. But the whole idea of this DDD is that we can try to adhere to it as long as we can. So this is the very important part. So don't try to be 100% to adhere 100% to all the patterns and principles, because this won't be possible, because you will have a lot of different restrictions that are imposed by other tools that you are using, like ORMs, for example, like messaging, like how to handle events and so on. So there will never be 100%. So there is never, or at least I never seen a real project for which you could say this is 100% domain-driven design. Okay. Then we will hear a lot, or you will hear a lot also of subdomains when it comes to domain-driven design terminology. And this is very important part, because subdomains and bounded contexts seem to be kind of like very similar, but they are conceptually different. Subdomains is more like a problem of, or it's a concept of the problem space, while the bounded context is more a concept of the solution space. And I know these type of definitions are very abstract, and I guess maybe also very hard to follow. But I have also here an example that I always like to give. And this is, for instance, let's assume we have a room. We have a room that is, I don't know, 3 by 3. And we know that in that room, we have to put a carpet. Now, what we can do, or maybe we have in that room already a carpet that is rolled. Now, when we unroll that carpet, it could be that the carpet is exactly 3 by 3 and it will 100% fit the room. But it also could be that when we unroll the carpet, it is not 100% 3 by 3, and in that case, it cannot completely cover the room. So in that case, we would try to think about how we can hide maybe the parts that are not covered, maybe with furniture and so on. And coming back to this idea of subdomain and bounded contexts, the room is a subdomain. So it is a problem space. We have a room and we have to fit it with a carpet. And then the carpet is the bounded context. It is basically the way that we try to solve that problem. Maybe we can solve it very easily, but maybe it won't be possible for us to 100% solve it, so that we have a carpet that 100% fills the room. So once again, this is the whenever you think, or whenever you hear these concepts, at least this is what I'm doing right now, or whenever I'm hearing the idea of subdomain and bounded context, I always think about the example with the room and the carpet. And then I always try to understand, when I want to use one of the words, I try to understand, am I talking right now about the room? In this case, I would use the subdomain. Or am I talking right now about the carpet? And in that case, I would use the bounded context as a wording, I would say. Good. Then the next part in it is what we call context maps. Context maps are very, very important in domain-driven design, because like we have here a picture as an example, we have a very huge city, which has a very also huge transport system. We can even think about, I don't know, subway or trams or buses and so on. If we go to that city, how do we know how to get from one place to another? And yeah, you probably say, yeah, you just Google it. Of course, yeah, Google would help us. But in the end, what Google does is also look up a context map. So Google basically has a definition of what the entire transport system for that specific city looks like. What lines they have, what buses, what lines are buses, what lines are subways, what lines are trams, and so on. So basically Google is able to tell you exactly how to get from one place to another using public transport, because it has a map representation of the entire area, and how pieces or how different parts of the cities are interconnected with or by this transport system. Our application, when when we'll work towards it, and it will become more and more complex with more and more classes and bounded contexts and so on. We also need to define these maps, because these maps are very, very useful, especially when we get, for instance, new members in our team. This is a first scenario where this type of maps are very, very important, because then they can find their way easier through the entire application. It also explains a context map in domain-driven design. It also validates or defines or describes exactly that the behavior that specific context should implement. And also, it could be that, for instance, as we said earlier with this example of a user class, if you are in one context, in a social context, then a user has first name, last name, location, and so on. But if you are in the context of billing, then the user has also a billing address, a payment method, and so on and so forth. And this is why these context maps are very important, because a developer or a newer developer to the project can simply look into those context maps and notice, okay, in this context, the user means this and this and these properties and this and this and this behavior. If I go over to another context map that describes a different context, then I see that, okay, I have a class that is called the same, but in this context, this class has these properties and this type of behavior, which could be totally different from the other one. Of course, there might be also some overlaps, but overall, in those two different contexts, those classes and subsequently objects that are created from those classes will have different sets of properties and different behavior. And that's why it's very important to keep track about our contexts and create those context maps for them, which is maybe a fancier word to say for a very good documentation that in domain-driven design projects usually would imply some visual aid, some visual graphics that would help us to easier understand what we have in that specific context. Okay. Then here at the last point, I say that cross-cutting concerns are resolved by the shared kernel, but about the shared kernel we'll talk just a little bit later. Then the next topic that is very, very important, and I like this topic a lot when I first started to read about ubiquitous language. And as I stated earlier, when it comes to domain-driven design, a key point there is that in the team that develops that application, there are developers, but there are also non-technical persons, usually the domain experts, but also maybe some other stakeholders that hold some stakes in that specific project. And all the meetings when we discuss, okay, what do we need to do, what problems do we need to solve, then of course we'll hit that scenario where we as the developers, we have a language that we understand, but non-technical people won't understand that certain language. And that's why in domain-driven design, this concept of ubiquitous language is very, very important, because this means that we all need to use the same language when we talk about the specific application. And this means that we as developers will usually be attentive at the wording, at the concepts that the domain experts use when they speak, and basically name our classes exactly the same way that those domain experts use those words. And behavior, we name it the same way. For instance, if, I don't know, we start to build our social application, and of course we as developers, we say, okay, we have a user, let's create a user class. But then in those meetings, we basically notice, or we hear that the domain experts there are speaking maybe, I don't know, maybe of subscribers. Then what this would mean in domain-driven design and using this concept of ubiquitous language is that these concepts that the domain experts use need to be exactly the same in the code that we write. So in this case, we would rename our class from user to subscriber. And this also means that we would have to pay really, really close attention at this type of speech. Because by the time the language becomes fractured, the project will face very, very big problems. For instance, if I don't know, you have one of these meetings where I said in all the meetings there are also the domain experts, and you as a developer maybe say something like, I don't know, when this is deleted. But then the domain expert thinks about deleted maybe in a different way. What does a deletion mean? Like, for instance, you would assume that a delete means okay, completely removing a certain record from a database, or permanently deleting a certain object from a list of said objects. And the domain experts would maybe think, or would say that for him a delete would simply mean to put that certain object in a state that it is not displayed anymore, but that it can be recovered. And then we see that when I as a developer talk about delete, and the domain expert that talks about delete, we mean actually two different actions. And this is the point where we will get some serious problems, and this is the point where this language will get fractured. This is why a very big part of domain-driven design is about consolidating this common ubiquitous language that we will use as a team for the project that we are working on. And in this case, everything that we use, or everything that the domain expert uses in his speech to describe behavior, it is simply exactly the same thing that we would have to use in our code. For instance, one other example. When a new user signs up for the application, for the social network, we would probably say, okay, we have somewhere, I don't know, in the application, maybe in a class, something that, or probably a method that is called create. Cool. But then we notice that the domain experts are never talking about creating a user. They are talking about a user subscribing. Then probably we should rename that method from this type of create into basically what the domain expert uses. In this case, subscribe. And in this case, when we ever talk about subscribe, also we as developers, but also the domain experts will always think about the same thing and about the same behavior. Okay, then when it comes to ubiquitous language, we generally, or we will see that a type of ubiquitous language dictionary will emerge for each bounded context, because in each bounded context there we might have, I don't know, objects that are called similarly to other bounded contexts, but their behavior is totally different. So in this case, it could be, or in most cases, we would have, I would say, a total different glossary or dictionary of ubiquitous language for each different bounded context. It should be used throughout all the context, which is very, very important, as I said. And the very important thing that we need to be to keep track of and be very attentive is that from the conversation to code. So what we hear in the conversation, the concepts that we hear, the behavior, the words that we use, or the domain experts use during that conversation, the exact same words should be transposed, I would say, in the code that we write. And I want also to clarify one thing. It doesn't mean that we always need to 100% follow the terminology that the domain expert uses. Of course, during or within our team, we can challenge those, or we can challenge that terminology, and we say, okay, but it doesn't really make sense to call creating a user subscribe. Let's call it create. And probably during this discussion, a term will emerge that will be acceptable for both parts, of both for the developers, for the technical part of this of the project, and for non-technical people in that project. And then we can transpose that specific part or that specific term to our code. Okay, then another very important thing that especially if you are the lead architect on a project that follows those domain driven design principles, One very, very important thing is that during the time, because these projects could take some time until we develop them, or basically they may be never finished, because there is always something new that you have to add there. But you have to pay attention and recognize the fact that a change in the ubiquitous language should always change or mean a change in the model or a change in the code that we write. And for me, this was something like, in a certain way, very, very important, because suddenly it became clear to me that if I'm a senior software developer or an architect on that specific project, if I notice that the ubiquitous language changes, then that change should be also applied to the code, because otherwise it will come to a moment when that ubiquitous language will be fractured, and then we are back to square one. So where we basically started when we talked about ubiquitous language. So once again, a very important part is to recognize that the change in the ubiquitous language should always lead to a change in the model, or a change in the code that we have. And such changes, when we already have very complex applications, are not easy to do, because there might be a lot of references and things that have to be changed. So this might not always be easy, but on the long run, it would give us, or it gives more benefits to the project than the effort that it takes to implement it. Okay, so let's have a short summary of glossary of terms. We have, first of all, once again, the problem domain, which is the specific problem domain, or the problem that we try to solve in a specific context. You might hear the word core domain, which would be the key differentiator, because the customer's business needs. Because in an application, you would probably see it, or a lot of times, you're not doing an application only for one problem domain. You're doing an application that usually will involve more problem domains. But in that case, there almost always is one domain that is the core of that business, and that is then called that a core domain. And the subdomain, once again, we can refer to it or think about it as the room. So within this problem domain or core domain, there are several different rooms, like in a flat, in an apartment. We have the kitchen, we have the living room, we have maybe a dining room, a sleeping room, and so on. So we have the domain, which is the whole flat. Then we have subdomains, which are problem spaces, so different rooms. And then we have bounded context, and in this example, it would be the challenge, okay, how to furniture all the rooms in that apartment. Because for the sleeping room, I might need a bed, but for the kitchen, I might need an oven, a fridge, and so on. And the solution that we find for that specific room is that certain bounded context, for which we would also need to create a context map. So this is the first part of the introduction of domain-driven design concepts. And we'll have to go further to another part, and we'll watch closer what it really means to focus on the domain. And we'll talk about domain models, about behavior. But what I want to do right now is to take a short break. I guess it would be around 5 minutes. And in 5 minutes, I will resum this presentation, and we'll talk about, once again, what the domain focus really means for us developers, how we design our classes, how we need to think about our classes. And then we'll go further to understand exactly how we can implement this in a social media application. So I will change the screen right now to reflect that we are on a break. You won't hear any sound during the break, but we'll come back shortly. So just stay tuned, please. Okay, I'm back. Before I continue, I have a really kind quest or kind request for you. Could any of you please write something in the comment area, because I just want to make sure that the comments are working. It's really important for me to know if I can get feedback. And once again, please do not hesitate to ask your questions, or if you want to add something, please write in the comment. What I want to do with this stream, I know that right now we are not that many viewers, but I really want to build a community in which we can communicate, in which you have questions that I can answer, or maybe that I can't answer, and that I will follow up maybe in separate streams. But it's very important to interact with me via the questions. So if you are not if you wrote something in as a comment, it means I haven't seen it unless I respond to it. And in that case, please scroll just a little bit down on my channel, and you will see a section where that is called social, and then you will find some links to my Twitter, to my Facebook. Please go there and write me a message and tell me that okay, the comments are not working, or that you have commented, so that I know that the comments are not working. So please write a comment if you can do that. Okay, now let's continue right now, and we will see what actually does it mean to focus on the domain. Because D in domain-driven design, the first D, of course, comes from the domain, which means, of course, that domain is very important. But why is that? Let us check. Okay. Now, the way Eric Evans defines this is, well, that the domain layer as a whole, is responsible for representing concepts of the business, information about the business situation, and the business rules. So state that reflects the business situation is controlled and used here, even though the technical details of storing it are delegated to the infrastructure. This layer, according to Eric Evans, is the heart of business software. So what does this actually mean? It means that when we are modeling our domain and our domain classes that we will usually call domain models, it's very important that these domain models encapsulate the current state of the specific model. It encapsulates all the information about the current business situation that we want to model, and the business rules that would apply to that specific objects, which would of course transfer to also that a domain model should encapsulate a lot of behavior. And we will see that a lot of things, or most of the things in domain-driven design, is about behavior. How we model a certain type of behavior, or how do we model rules of that specific domain in our application or in our domain model. So let's go one step further. As said, basically what we have here in domain-driven design, when we think about our domain layer, is that we have to focus on behavior. And if we think about this social network, or let's go at it the other way around. Usually when we create software, and this is also the way I almost always did until I started to study those principles of domain-driven design, is okay, we have, I don't know, a user. Okay, what properties does the user have? It has a username, location, a post title, whatever, post content, whatever, this type of properties. And then I would write a bunch of properties in my class. I would maybe add a constructor, maybe overload the constructor to take some input parameters at it. But then that would be mostly it. Then, for instance, if I want to perform some actions on that specific object, or an object instantiated from that class, then I would probably have some services that would handle that. And this is what we will call, and we will have a slide about it, an anemic domain model. And this type of anemic domain model is very often encountered, especially when we are developing APIs. But in domain-driven design, this type of models is really not a best practice, so it's not a pattern that we should follow. When we think about a domain model, we have to think about behavior, about methods basically, instead of properties. Properties come naturally when we think about the behavior, the things that object should do, should be able to perform. And in this area of a social network, this would mean that when we start to model, for instance, our social bounded context, we will think about things like making a friend request, or sending a friend request, or creating a post, or liking a post, or maybe actions like accepting a friend request, or removing a friend, editing a post, deleting a post. And our focus should be to model this behavior in our classes, not the properties. As said, the properties will come natural when we start to model this type of behavior, or all this behavior in our domain model. And as said, this type of models where we have just a bunch of properties and maybe a constructor or two are usually called anemic domain model. And this is not the best practice when we are working with these DDD patterns and principles. What we have instead, or what we should strive towards, is a rich domain model. A rich domain model is nothing else that a domain model that reflects the behavior, that is primarily focused on behavior. What is that model supposed to do? And this is also the place where we define the business rules and the changes that will maybe occur in the state of that specific model. Of course, this brings a lot of complexity because we will have to think about state changes. How do we handle state changes in rich domain models? And of course, we'll talk about these things while we will code all this stuff during the next streams. But what I wanted to say right now is that when we develop web applications, handling state is maybe easier, but if you're developing, I would say, like long-running applications like a desktop application, then handling state would be a lot more complex than for web applications. Because for web applications, in the end, no matter if you follow domain-driven design or not, basically or mostly everything is bound to a certain request that comes in. But when we have long-running applications, then the creation of objects is not bound to a certain request, and we can create an object that is long-lived throughout the entire lifetime of the application. So as long as the application runs, that object is there, and in that case, tracking the state changes is far more difficult. But in the area of web applications, I don't say that we don't have to track state changes, but this is a lot easier than in long-running applications. And here is a very basic example of what we would call an anemic domain model, which would be a product that has a bunch of properties like ID, code, name, description, and price. And that's basically the entire class. We can simply use that class also to persist it, because it just has these properties, so it's nothing fancy about it. But in the end, when it comes to domain-driven design, we see that this class doesn't model any behavior at all. It doesn't have any business rules. It simply is not a domain model according to DDD patterns. Instead, what we could have here is then a rich domain model, and in this example you see that we concentrate a lot on behavior, which is here accept a connection request, change information, change body information, for instance, in a certain application. All these type of things represent behavior, so things that specific object is supposed to do. And of course, it would have to also adhere to a certain set of business rules or criteria when it performs those type of actions. So once again, when it comes to DDD, it's very, very important to focus when you create your classes, your domain classes, to always focus on behavior and not on the properties. And this, if you do that, it will only come natural that your classes will have a lot of methods and very few properties when you compare it from the or at least when you compare the proportion between properties and methods. But then another very, very important topic is when we talk about domain models and classes in the domain model, is that in domain-driven design we have two types of domain models, I would say. We have entities and we have value objects. And the entities are very simple, and I would assume that it's something that it's very familiar to us, because when we develop applications, we normally think about our objects like entities, or about our classes like entities that would eventually be also persisted exactly the same in the database. So basically, many objects are not fundamentally defined by their attributes, but rather by a threat of continuity or identity. So what does this actually mean? It means that an entity is always uniquely defined or identifiable by a certain ID. Of course, the ID could be of different types. It could be an integer, it could be a long, it could be a GUID, whatever. But each object or each entity is uniquely identified throughout that specific ID. And this has a very important implication, for instance, when we do equality comparison for entities. Because equality comparison for entities would always basically only take into consideration the ID. So as long as we have two different, or we have two instances of the same class, and if those instances have the same ID, the same identifier, then those are equal. If they don't have the same ID, even if all other properties are the same, then these are two totally different entities and they are not equal. And why I do say that this is important, because thinking about our social network, let's say we have this idea, for instance, of a user. And let's assume that the user is defined for now just by a first name and a last name. And we have a user that has a first name Dan, like me, and it has also a last name that is also my last name. But then we have a separate user. It could be a totally different person, maybe also from a different country, that has exactly the same name and exactly the same last name. From our social network perspective, are these two users equal? Of course not, because there are two different entities. We have on one side the first user, and on the other side the second user. But those users, even if their name matches, they should be treated differently. So this is why each of those objects will get its separate ID. And if we compare equality between them, it will be false, because as long as the ID is not the same, then if it's clear that we don't have any type of equality right there. Just 1 second. Okay, let's go further. Okay, so this is the entity, the ideas or objects that are basically defined by a trait of continuity, also called an identity. And this means that all our objects will have, or all our entities will have an ID field. Okay, then mostly these entities are the objects, also when we follow domain-driven design principles, that we will eventually store in the database or persist in the database. Entities, it's very important, are mutable, so they can change over time. For instance, if I go back to the same example with the user, I have a first name and I have a last name, but I don't know, maybe I changed my last name. Am I a different entity right now? No, I'm exactly the same. I'm exactly the same entity, but there is only one thing that changed about me, that mutated. So this is why entities in domain-driven design are always, I don't know, or could be changed. So we never have only one single identity that will remain exactly the same over time. Of course, the only thing that won't change about that entity is the identifier. That will stay the same. But all the other properties and maybe even behavior is subjected to change. As said, in this case, or as a result of this concept, the equality is implemented always based only on the identifier or the identity. So if two identities are the same, if we have the same identifier, then two entities are equal. If not, they are not equal, even if they have all the other properties matched together. Then the responsibilities of entities in DDD is, of course, to manage the identity and the life cycle of that entity throughout the lifetime of the application. And I would say maybe throughout the lifetime of that entity being persisted in the database. But once again, here I added this, but this comment that I added was only when I look from the perspective of the entire application. When I think about it only from the perspective of domain-driven design, then it means that the responsibility of an entity is to manage the life cycle of the specific object until it is disposed or garbage collected or whatever. Because whenever we need to retrieve that object again, it basically starts a new life cycle for it. Okay, then the second type of domain models, which this is something that for me at least it was new when I read about it, and it was for me something like, wow, this is really cool. And this other type of domain model are called value objects. Now, value objects are very interesting for different reasons. They usually measure or quantify or describe a certain thing in the domain. This means that it's basically, or we can identify them based on the composition of their values. And what does this mean? It means that here in this case, when we check for equality of two value objects, we have to take all their properties into consideration, or whatever the business rule define as properties for checking equality, because we can only take a subset of the properties when we check for equality. But again, this depends on the business rules. But unless we have a concrete business rule that defines exact what equality means of two value objects, then it by design means that we would compare all the properties, and only if all the properties match, then we have two value objects, two equal value objects. Another very cool thing about value objects is that they are immutable. So it is forbidden, according to DDD, for value objects to change. This means that basically whenever you create a new value object, or you want to change something in a value object, you basically will create a new one. This is a very important pattern in DDD. And I can also give an example. And I talked about the idea of name when I was talking about a user as a class. But then this name, of course, this is what we would always do. We would basically normalize it into different other properties. So we would have a separate class that is called name, that would have maybe a first name, a last name, initials, and whatever other property we would still need on that specific name. So in this case, if I have a name, a very abstract idea of a name that has a first name John and a last name Doe, if we have another object of the type name that has the first name Joe and the last name Doe, are those two objects equal? Yeah, they are equal because they refer to some very abstract thing, like something that measures something that measures or describes how a certain object looks like. In this case, in this case, a name. But you can interchange them in the logic of your application, for instance, and nothing would change for the application itself, because even if they are two different objects, they are essentially exactly the same because they share the same set of properties. And usually, when we try in our application to define things like names, like measurement of units, things that you can easily interchange one for the other, then we would have to create those objects as value objects according to domain-driven design principles. And one other important thing about this is, as said, they have no side effects. What does this mean? As said, if we interchange two value objects that are equal, nothing should happen there. So the application would not be affected in any way. And this is a very huge difference in comparison to entities, because in the logic of the application, we cannot simply interchange two different entities. This would lead for our application to break. For instance, if we have two users, one user might have certain rights on the application, the other user might have a different subset of rights on the application. And if I interchange them, everything will blow up. My application will fail, and I would have a lot of different exceptions there. So in case of entities, we cannot simply interchange them. But in case of value objects, like for instance a name, whenever we interchange two names that are equal, there is no problem. So as long as you have the first, the same first name, the same last name, and we interchange them, nothing will happen in our application. So there won't be any side effects. Okay. Then here is what von Vernon tells us about value objects, and he says that it might surprise us to learn that we should strive to model using value objects instead of entities whenever possible. And this is a very, very important thing to understand. And even when a domain concept must be modeled as an entity, the entity's design should be based towards serving as a value container rather than a child entity container. What does this basically say? Again, maybe here this language is a little bit complicated, but what this essentially means is that whenever we create a new class in our domain model, we should ask ourselves, if I create an object that has the exact same properties with the different objects, are those objects equal or not? And if those objects are equal, then it means that I should create them as value objects, even if I would tend to create them as an entity. And let's give a very specific example for a social network on this. We have a post, and on this post we have comments. So all the user can comment on our post, which is great. But then I write something there. For instance, I don't know, I write hello world as a comment, but then another one of you would come and comment to the same post and say hello world again. So then the question is, are those two comments equal? Because they have essentially the exact same string. It's hello world. So are these comments equal or not? In this case, so strictly speaking from this perspective, it means that, okay, they are certainly different because they are coming from two different persons or from two different users. So in that case, my first hunch would be, when thinking about this, okay, then it means that comments are entities. But then when I talk or when I think further and I say, okay, I write a comment which is hello world, and then I write another comment, so it's still me, that says hello world again. In this case, are these comments equal or not? Or not? And for instance, in this case, it's the same user that wrote that comment, and it's the same comment body. So are these comments equal or not? And this is the beauty of domain-driven design, because the answer to that question is not really clear, but it really depends on the domain and what we agree or what the domain expert tells us about it. Because if the domain expert says that, okay, so the same user is allowed to post the exact same comment twice, then this means that, okay, this comment could also or could easily be an entity. And then no matter if I post at the same time as the same user with the same message, each time I post a comment, it will get a new identifier, and then all those comments will be basically unique, even if we consider them, or even we as users would say that they are equal because they contain the exactly same string. But if the domain experts tells us actually no, these comments basically are equal, and we shouldn't allow them on our social network, so we shouldn't allow duplicated comments or comments that have the exact same message. in that case, suddenly we can think about the comments as value objects. Because in this case, or in that case, it really doesn't matter if they have the same ID or not. They are essentially, whenever I write a comment, it's there. I will never compare it for the identity, or I never compare it as an entity. I will always compare these comments as value objects. And for instance, if I say that they are not allowed on my social network, when I check for equality, I would check, okay, is it from the same user? Is it, I don't know, the same message? If yes, then I simply won't show that duplicated comment on my social network. And subsequently, I won't even store it in the database. And here comes another very important aspect. Don't think that only entities are persistent in the database. No. In domain-driven design, it really doesn't matter if it is a value object or an entity. If it needs to be persisted, it will be persisted. And here, for instance, this is one spot where the ORMs and especially Entity Framework Core or Entity Framework generally will bring us a problem, because if we want to store value objects in the database, from the domain perspective, they wouldn't even have a property called ID or something similar. But for Entity Framework to work, we would have to create such a property. And in that case, a good thing at least that Entity Framework allows us to have private properties as IDs. So we would probably simply add to our value objects a property which is called ID that has the only purpose to be or to make it friendly or to work good with Entity Framework Core. Okay, good. Where to put the domain logic? Then this is the next very important questions. And of course, both entities and value objects encapsulate business logic. So once again, it doesn't mean that business logic are there only, or we have business logic only in entities. No, we have business logic also in value objects, and this is a very important thing to think about. We'll talk just in a few minutes about some other concepts like aggregate and aggregate roots, and then we can talk in a little bit more fine-grained manner about, okay, where to put a certain logic depending on what the place of that specific object is in the entire aggregate. But we'll come to that just a little bit later. Then another very important topic are domain services. And domain services according to domain-driven design are basically services that model behavior or logic that belong either to an entity or to a value object, or that belong to a certain domain model. Now, a good domain service has some few important things. First of all, it should be, or it should feel like a very natural part of that specific entity or value object. It usually, I don't know, converts currencies, or converting currencies might be something like a service that would be a domain service. If we build an application that, of course, works with currencies, then it should have an interface defined in terms of other domain model elements. This means that each service, but this is really nothing something new. This is what we usually do. That services are I would say exposed throughout an interface that is defined at domain level or in the higher level modules, and then we use dependency injection to use those services. And one important thing is that services or domain services from this perspective of domain-driven design are stateless. So a service shouldn't contain any type of state, or if the state of the service object changes at a certain point, it shouldn't affect the behavior of the application at all. And here, for instance, we have an example, like we have two different entities and a value object. We put them together in such a domain service, and it basically outputs a certain result. So this would be a very common use case for what a domain service might look like. So domain services, from this image, we can also think that we would use domain services whenever we have to perform certain type of behavior that extends outside of one specific entity or value object. And in this case, we need kind of a service that would, in a certain way, synchronize the information from the different entities and value objects, and then work out the result between them. So this is the way we should look we should look at domain services. Once again, as a glossary here for these parties, we have first an anemic domain model, which is model that usually consists only or mostly of properties. Then we have a rich domain model, which focuses on behavior, and this is the type of domain model that we should aim to from DDD perspectives. Then we have entities and value objects that are very, very important, and then entities, or sorry, valuables, value objects, or sorry, entities should be, once again, value objects should be immutable. Good. Let's go now one step further, and we'll introduce a couple of new concepts here right now. And it is the concepts of aggregate and aggregate root. An aggregate, as defined by Eric Evans, is a cluster of associated objects that we treat as a unit for the purpose of data changes. What does this actually mean? Well, it means that aggregates consists of one or more entities or value objects. And we need to treat them like a unit when it comes to state changes. And here we can take once again this reference to the user class in a social network. Now in the user class, okay, or let's define, or let's think about user as an aggregate right now, and I will tell you in a few minutes why. So when we think about a user as an aggregate, it means that, okay, this user has a name that will be probably a value object. It also means that this user would probably, have a list of friends, which would also probably a list of value objects, or it could be a friend, could be an entity. In this case, it would be a list of entities. It would have an address that would also most probably be a value object. It would have a location that would also most probably be a value object. And then when we think about changes, so what does this mean? When something changes to the user, maybe at the name level, will this change in any way affect all the other parts that the user is consisted from? And this is a very important question that we need to ask ourselves, because in the context of aggregates, or in the boundaries of an aggregate, we always have to check for state consistency. And for instance, if something or some part of the application tries to do a change to our aggregate that would put the entire aggregate into an not valid state, then that change shouldn't be performed. And it could be, for instance, that we maybe we want to change the first name. And let's say that we say, okay, we want to set the first name to the letter A. But then we have maybe a business rules that says that, okay, first names should be at least 3 letters long. So in this case would mean that if I change the name, again, it is a value object, to have a first name that consists only of 1 letter, it would basically change the state, or bring the entire aggregate, the entire user, into an invalid change, into an invalid state, which in this case will probably trigger an exception. So at the aggregate level, we should make always sure that everything that interacts with our aggregate doesn't put the entire aggregate at risk at being in an invalid state, which is very important. And this means that at the level of the aggregate, we need to keep track about the valid state of the entire aggregate. So when something changes, whenever something changes, we have to keep track of the state of the entire aggregate, not only of that specific object that is part of that aggregate. And this is really, really important. Now, aggregates in domain-driven design always also have an aggregate root, which is basically the domain model that acts as the root for the entire aggregate. And coming back to this user example, now we can say that we would create a class that is called user. And in this case, this user class would be considered as the aggregate root for the entire user aggregate. Aggregates can consist only of one class, and in that case, the aggregate itself and the aggregate root would be eventually the same, so there wouldn't be any big difference. But the idea is that each aggregate should have at least one, or should have an aggregate root. It cannot have two, but it needs to have one. But once again, an aggregate can consist only of one aggregate root. And this means that in this aggregate root, this is normally the place where we keep track of state changes and guard or keep watch that any change that is requested for any part of the aggregate wouldn't lead to the entire aggregate to be put or to become or to get an invalid state. So this is the importance of the aggregate root. And I just want to also state here that we will dive deeper into this when we'll develop our data access layer. But the aggregate root is usually the entity or the object that we store in the database, that we persist in the database. Okay, invariants. This is also a very important concept in domain-driven design. And an invariant is a condition that needs to be true for the entire lifetime of the aggregate to ensure that the system is in a consistent state. What does this mean? Basically, invariant defines a list of rules, actually, that must be all of them true at the same time, so that the entire aggregate is in a consistent and valid state. And in this case, the aggregate root, as said, is responsible to handle all the invariants. So when something needs to be changed to the model, what we need to do is simply to check for all the invariants, so all the rules that needs to be true at the same time, so that the entire aggregate root is valid. And sorry for my phone ringing right now. I forgot to put it on mute. Sorry for that. Okay, if we go one step further, then the aggregate, as said, is responsible to handle all invariants and makes sure that all the invariants in the aggregate are always set to true. In other words, the aggregate root must ensure that the entire aggregate will remain in a valid state. So essentially, what we say here is that our invariants are basically the concept or the way we make sure that our aggregate always stays in a consistent state. Okay, then relationship between aggregates, and this is a very, very important point in domain-driven design. And here, for instance, we have an example where we have a customer aggregate that, of course, holds all the information about the customer. Again, an aggregate could eventually have a lot of different classes, like different entities as properties or value objects. And we have here also the order aggregate. And this type of aggregates would, at a certain point in the application, need to interact the one way or the other. And the customer, for instance, might have an address. Now, the idea is that in the order aggregate, when we, for instance, need to check for the address of a certain customer, what we usually do when we develop is that, okay, we go to that object and we check that address. And maybe if we need to change that address, we even change it. But according to domain-driven design, this is not the way to do it. So if in our case, we want to follow domain-driven design, and we are right now working on this order aggregate that needs to do a change to the address, it won't simply change the address. It would simply go to the customer aggregate root or to the customer aggregate, and it will say, hey, the address needs to be updated. Then this aggregate root should try to update the address, or should decide based on the invariants if the update of that specific address is okay or not. And then the aggregate root can fulfill the request for change or not, and simply return maybe not an exception, but a response, a result to the order aggregate root, and say that, hey, the address cannot be changed. But once again, here important is that the order aggregate doesn't change anything to the customer aggregate. Let me right now know, please know if you see the screen blurry or not, because I think it might be a little bit blurry. Of course, you can use the comments to let me know that, and I try to see what can we do to change that. I wanted to finish with this part by saying that it's very, very important to note here that when we need to interact between different aggregates, we will heavily rely on encapsulation. Now, I knew about encapsulation and what it was and how it is used, but in my opinion, I think that I never fully understood how really vital encapsulation is in programming until I have started to work according to the domain-driven design patterns and principles. Then I realized that, hey, all the properties in the customer will be encapsulated, and their setters would be set to private, so that nobody would be ever able to change the properties. If a change for a property is needed, then the aggregate root should be notified, and it should check the invariants, and if it's possible to make the change without putting the entire aggregate on an inconsistent state, then this would be done. Here we also have a glossary with terms that we use. But I think that you can see the screen correctly, so it's okay. So we have the aggregate, we have the aggregate root, we have the invariants, and we have the persistence. I also want to add that this stream will also be available as a recording, also here on Twitch, but I might also upload it on YouTube. So if you want to come back later to check back these terms, these glossaries, you can come back and watch the video, the recording, and search for what you are working at or for what you need. Let's go one step further, and we're almost done. Let's talk a little bit about our social network. So what we will do is during or within this stream, as I said, it will probably take months, but the aim is to create a social media application from scratch that would be used in a university. So there might be some features that are related to how would we use this application in a university. And here I outlined a very few requirements of that. Of course, I must be honest, I really don't know, or I haven't written down all the requirements for the application so far, but this is the point where I really count on you as a community to come with feedback. And by the way, if you scroll down on my channel, you have also a suggestion box, and you can use it to write your own suggestions. Other users can vote for suggestions, or upvote them or downvote them. So this is the way that maybe we can even define together what features do we want to have in our social media network. But generally, we would have three different type of users. It would be students, teachers, and staff. Teachers and of course staff should be able to create and manage schedules, and then we would also need to have a gradebook feature in the social network, so that of course teachers can then write down the outcome or the results of the different exams that each student in a certain class has taken. Now, if we take a very close look at these 3 points, what these points basically define are already 3 bounded contexts. We will have a bounded context for users, which will be students, teachers, and staff. We will have a bounded context that will handle everything that is related to schedules, how to create schedules, how to assign them to users, what users can do with the schedules, and so on. But everything would be within this bounded context of schedules. And then we have the gradebook as a new bounded context, where we have all the business logic that will be related to gradebooks and how gradebooks are created, how results are written, how the results are changed, and so on. So we will have already 3 different bounded contexts. But if we decide to let's say to make the application even larger, maybe add pages like for each individual faculty in a university, then we would have a separate bounded context for the pages and so on. But this is kind of like the skeleton that we'll be using. Now, going one step further is okay. How we will go about the application from the architecture perspective, and here there is one very important part, and I think maybe because it kind of, the video or the camera covers just a little bit the image, but nothing from a very big importance. But if you read or if you read or constantly read what Jimmy Bogart writes and talks about at conferences, it's this type of onion architecture that he came with. I think it's already a few years back. He changed it a lot. In the meantime, he names it right now vertical slice architecture. But generally, what I wanted to point out here is how we will basically define our folder structure in Visual Studio. And we'll follow this type of onion architecture. At the core, as Eric Evans also said, is the domain layer. So right now, at the core will be we will have our domain classes, our domain models with all the behavior, the logic, the invariants, the aggregate roots, and so on. Then we would have an outer layer, which is the data access layer. Of course, that layer would be responsible to handle data persistence. Then we would have a separate infrastructure layer. This is kind of like a personal preference. I saw projects and I think it's okay if you have one infrastructure layer in which or that comprises also the DAL. But I like to keep them separately, to have the DAL only for data access and the infrastructure layer for all the other infrastructure that I need, networking, HTTP, whatever, cloud services, whatever I need, anything else in that application, which are external resources, I would put them in this infrastructure layer. And then we have the application layer that could be, I would say, a consolidated application layer that can be used by different front ends. And if you look here on the left, basically I have here web, APIs, and mobile. This would be basically the presentation layer. So we would have only one application, and in this case we will have, or we could have a web front end to it, and then we would have a web front end in the presentation layer that it would talk to the application layer and to the infrastructure layer, DAL, and so on. We could build an API as a presentation layer, and we even can build a mobile app as a presentation layer. The important thing to note here, or why I kind of like to graphically always show this idea of onion architecture, is because here we can see exactly how do we plan to implement dependencies, or which layers will depend on each other. The idea is that domain layer, or the domain layer that we can see here, it won't depend on anything in the entire application, with the exception of shared kernel, but we'll talk about the shared kernel just in a few seconds. But here we see that here we have these arrows, like the blue arrows or the white arrows, that indicates dependencies. And we see that the domain layer really doesn't depend on any other layer except for the shared kernel, but this is something that is totally separate, and we will talk just in a few minutes about it. Then we have the document, the data access layer, and this data access layer depends on the domain layer. So in the data access layer, if we have a project, a dull project, we would add a dependency to the different projects that we might end up having in the domain layer. But we will never add in the domain layer a dependency on a project that is part of the dull layer. Then if we go further throughout the outer layers of this onion, this would be then the infrastructure layer. And we see that this infrastructure layer, basically, I think you can also see it, it can depend on the infrastructure layer, of course. It can depend on the domain layer, but it cannot depend, or it cannot have references on projects that are placed or that we consider as being the application layer. Then, of course, the application layer, which is the outmost layer of this onion, would then of course depend, or we could depend in the application layer on projects that are in the infrastructure layer, data access layer, or domain layer. And if we keep always in mind this idea of how dependencies should flow, then our project would mostly be very, very clean from this dependency, from the perspective of dependencies. And of course, the presentation layers, the different presentation layers like web and API and mobile would or could depend on projects that are placed in each of the other layers of this onion, let's say. Good. Then we have the shared kernel, and this is a very important concept for domain-driven design, because there might be some type of classes or objects that are not fully domain classes, or that are not domain classes, but that there are, let's say, even maybe also common throughout the entire application, no matter in which layer we are and no matter in which bounded context we are. And here we could have, for instance, things like, I don't know, units of measurement, time conversions, maybe some basic exception handling. So all this type of cross-cutting concerns that will be used throughout the application, like in the same form, those are put in the shared kernel. And for instance, here we could put, let's say, some services that would convert between time zones. Again, this might not be something that belongs to the domain, at least not in the way that we define it so far, where we have a social bounded context, where we have a schedule and the gradebook context. Of course, none of them will be responsible for handling time zones. But on the other side, it might be important to know about time zones. For instance, when we, I don't know, write a certain result in the gradebook. When was that result written? So in this case, maybe we just think that, okay, we have a date created, and then we have to decide, okay, what the date should look like. Should be a date time, should be a date time offset, or we would use an external library like a Noda time to handle time, which is what I usually prefer. But probably everything regarding time conversions, then I would put in this shared kernel. And I think you can get an overall idea. So all cross-cutting concerns that are used throughout my application, but that are not infrastructure. So we don't put in the shared kernel, I don't know, communication with external resources. So cross-cutting concerns that concern the entire application, but not external resources, I would then put in that shared kernel. So this is why the shared kernel in domain-driven design is kind of like a little bit special, because the domain layer or projects in the domain layer can depend on projects in the shared kernel. Because if we need to work with time in the domain layer, this is not a responsibility of the domain layer itself, but we can then import the project in the shared kernel where we define time, and then we can use it. So the shared kernel is the only exception in the domain layer. So we can depend in the domain layer only on projects that are in the shared kernel. And this is what we will also basically aim to do in our application. Next Wednesday, we'll start directly by writing code. We'll create then the folder structure that we need. We'll create the solution from scratch, and everything that we need. And we're gonna be starting coding. Of course, starting with entities and starting with value objects, because we have to define an abstract class for entity and value objects. And we'll see how we'll proceed to that. Right now, well, I think that this would be a great time if you have any questions, just to post them here in the chat, and I will try to answer them. If you don't have any questions right now, but if you remember something maybe later, as said, on this Twitch channel, if you scroll just a little bit more down, you will find links to all my social profiles, so you can get in contact me right there. Also, very important to note that on this Twitch channel, again, if you scroll down, you will see you will see a part where I have a list of GitHub repositories, and right now there is only one GitHub repository right there, which is called Twitch UniConnect. And that would be the repository that I will be working on during this stream. So all changes that I will do during the stream will be saved in that repository, probably in separate branches, but also merge to master. I don't know exactly yet how I would do with the branching strategies. Not that I really have to think about it, because we'll never really deploy it. But well, I think maybe it might be useful to have a history of all or of the state of the development of that application from stream to stream. And in that case, it might be useful that I would create one branch for each stream. So if you want to follow along, you can you can head over to GitHub, clone that repository, and sync then the changes after each stream. And this would mean that after each stream, you will have basically all. Or you will have the exact state of the application that I have, and from which I will continue during the next stream. So right now, seeing that there is no question here in the chat, I would like to thank you very much for attending this first live stream. It was really my first one. It became also a little bit long. I hope it was not too boring. And I hope really that you have learned some new things here. And if you come back next Wednesday, you will surely notice how important it is that we have gone through this type of presentation before we start coding. Because when we start coding right from the beginning, we will be faced suddenly or immediately with the concepts that we have talked about today, like entities, like value objects, like how are defined entities, how are value objects defined, how we implement equality in each of them, because we have to implement equality, and so on. So I hope to see you all back next Wednesday. If interested, I will also do another stream tomorrow. In that stream I will mostly talk. It is called Tech Talk, and it won't be not that technical, but it's just a stream in which I also want to have people invited and to talk about well, the tech world, but in a way that is not really only for techies, but also might be interesting for other users. For instance, tomorrow I will be talking about contact tracing apps. What has been done so far, what has Google and Facebook, Google and Apple done, what applications are there right now, what technologies are used, what are the data privacy concerns, are they really useful or not. So all these type of topics I will discuss tomorrow, starting at the same time at 7 p.m. Eastern European time. Thank you very much for watching again, and I wish you a very pleasant evening.